In previous lessons, we discussed Scada systems and the components within them. Here is a quick recap of what was previously discussed. Scada is a collection of hardware and software components. Plant floor devices such as pumps, valves, and transmitters transfer real-time data to processors, such as RTUs or PLCs. That data is then disseminated to various devices within the network, such as human-machine interface terminals or HMIs, servers, and computers. Images of these processes are presented to operators for various types of interaction. In this lesson, we are going to discuss the role that a Scada system may play within a water treatment plant. With a short recap, we know that we are going to have both a hardware and software collection. For the software, we will use some software package such as Wonderware, Citect, FactoryTalk SE, etc. That software will be used to create the interface required to view and operate the control system. We will also have a hardware collection. That group of items will likely consist of pumps and motors, valves, switches, and transmitters, among other things. We also know that these components will communicate with a processor of some type. These processors, in turn, will allow the components to be viewed graphically on the Scada system. Pictorially, this hardware presentation may be as simple as flat lines that represent pipes, simple graphic representations of valves, and motors that may change color according to current status, such as opened or closed for valves and running or stopped for the motors. The appearance can also be very elaborate with 3D graphics of spinning motors and rotating valves. More likely, though, something in between, with 2D piping that is possibly color-coded, based on process, and field device graphics that change color according to conditions. The reason the latter is more likely is many plants are interested in graphics that are less complex, such as textual displays, or simple gray tone objects that only change color when in a fault or abnormal condition, versus spinning or complicated 3D graphics that may create distraction versus provide immediate information. The role that the Scada system plays within a water treatment system is vital for ensuring the quality of the finished product. That function begins with the graphical interface. Typically, the layout of the graphics would be similar to what may be seen on process piping and instrumentation diagrams, or PNIDs. If you are not familiar with what a PNID is, essentially, it's a two-dimensional drawing that depicts the layout of the hardware collection we said we would have in the Scada system. These drawings would show the piping layout with pipe sizes, the location of instruments, valves, motors, etc. within the piping, as well as symbols indicating what signals will be passed to and from the processors in the system. The controls engineer would take those PNIDs and create a group of graphical screens that would contain all pertinent information that an operator may need to interact with and control his or her water treatment system. Depending on the plant preference for graphics, minimally, the screens would include some numerical information for process instruments, and probably the unit of measurement, such as GPM or gallons per minute, pressure readings in PSI, etc. Most systems would allow for some sort of manual manipulation of devices, such as manually opening or closing valves, or running motors via buttons located on the screen. Process set points would also be located on a screen. These set points may be used to modulate valves to maintain flows or pressures, start, stop, or vary the speed of motors, select which equipment to run, or how many pieces of equipment to run to produce the desired quantity of water. The set points might also be used to indicate alarming when a process reading is outside of some defined limit. This alarming function, which is an integral part of a Scada system, would inform the operator of process excursions, alerting plant personnel that the expected quality may be impacted. With this knowledge, personnel can apply various changes in order to bring processes back within the expected limits. Considering the Scada system is the collection of various components, we know that they will all work together in order to accomplish the expected goals. We also know that the Scada can historically log process variables and, in some very advanced systems, use this historical data to predict outcomes and provide advance warning to personnel when something seems amiss. In summary, today's Scada systems play a vital role in the implementation and control of water treatment plants. Whether we're talking about fresh drinking water or the processing of wastewater, controls engineers, plant personnel, and city industry managers are all likely pleased with the advances made over the decades. That progress with Scada has allowed for more remote control of these processes, less manual interaction and control, and more advanced functionality, which help to ensure a quality finished product. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.